Hi everyone, my name is Marco, and the slides are not working. Yeah, you can do it. I crashed it. Yeah, success. Okay. What happens to the slide? Okay, here we go. Okay, my name is Marco. That's my avatar. You may know me from GitHub. My name is Sokramis there. I'm part of the Doctrine team. We are a PHP project that works on persistence. And we basically build ORMs and similar stuff. I'm a Zen Framework 2 contributor. And you can find me on Twitter or on GitHub at this handle. I follow some projects right now, just a bit of them. Why? Well, I'm having fun in doing that. The truth is that I work for Satan. But really, I'm having fun with it. Okay, now we're going to talk about the proxy pattern and specifically in PHP. Who knows what a proxy is? Okay, well, quite a bit. Okay, maybe there's something also for you. Okay, what is a proxy? A proxy is basically something that is acting as an interface to something else. So basically, it's something between us and someone we want to talk with. And this is carefully copy-pasted from Wikipedia. But the concept is really simple. So you see here, you see this deer, okay? The truth is that nope, it's Jack Testa, okay? The idea behind the proxy is that the proxy looks exactly like the real object that we want to communicate with. So the proxy communicates with this real subject. We call it real subject from now on. And this allows us to use the proxy thanks to the Liskov substitution principle wherever we will use the real subject. So let's put it really simple, really basic again. Let's say we have a subject proxy and a real subject, and those objects implement the same interface. It's something about selling stuff, buying stuff, you don't know. It's an interface, okay, and they look the same, which means that a client that wants to use the subject interface can actually consume either a real subject, so like this, or it can consume a proxy for it, so like this. So we just replaced the element in the middle. It looks the same. That's the concept behind it. In PHP, PHP developers are really lazy. We don't write a lot of interfaces. Yes, it's a sin. But we can simplify it a bit. We basically say that the subject proxy extends the real subject. And that allows us to just use it wherever we want, because you don't know whatever other people are using with this object. You should really use interfaces. Okay? So what? Okay, these are basic concepts, nothing new so far. What do we actually do with these proxies? What are they good for? I am not saying that proxies are a good thing. They solve some problems. They make other problems. We'll see a couple of them now. From the Gang of Four, we have mainly 4 types of proxies. We have a remote object. We have a virtual proxy. We have protection proxy, and then we have a smart reference. The remote object, as the term says, is something that is located somewhere else. It is an object that is in another address space. Another address space means that it may be on the same machine, but somewhere else in our program. It may be another running program. It may be on another machine. We don't know that. A virtual proxy is mainly used to initialize lazily initialize large objects, like we want a video and we don't want to load it all in memory before working. A protection proxy, which is basically what a firewall does, it disables access to an object's API based on some rules. And the smart reference, which is good for aspect-oriented programming. So how many people went to the aspect-oriented programming talk yesterday? Okay. And how many went to Joe's talk about data? about processing data. Okay? This is all about the stuff. Okay, this is implementation details now. They talked about the theory, now you'll see the implementation about it. Okay, so for fancy terms, we still don't know what we can do with that, but yeah, it's cool, okay? Fancy words, sounds really cool. Let's talk about the remote proxy. Remote proxy is basically a way of connecting some representation, which is in another address space, to a local object, which is in our memory. We want to basically work on an object, and this object is not really there, it's somewhere else. It basically happens this way. We have usually a proxy, and this proxy communicates with a client component, and this client component somehow communicates with the server component, and this server component has access to the real object. This is how it usually works. This is the normal example. So basically, like, if you have to work with SAP, I'm really sorry for you, but if you have to work with SAP and you work with a remote object on the SAP system, like a product, and you don't want to every time ping SAP or explicitly write the calls to the API, write a proxy for your object, and your object is actually on SAP, but you're actually using it directly. Let's make an example of it. So the idea here is that we have a tweet object, so we're communicating with Twitter in this case. And the tweet object is basically really simple. I build it, I pass data to it. It is a newable in this case. And then I have a getTweet method, and this getTweet gets some part of the data and returns it. Really, really simple. So this is really simple, it's easy to test. It's nothing fancy. What we can build is a tweet proxy that extends our tweet object. And what we do is that we override the constructor. Our tweet object doesn't contain any data anymore. What we do is we pass a tweet API, a Twitter API object to it, and an identifier for the tweet. And what happens at runtime in the get text is that the proxy actually uses the API to retrieve the real data. So the data is never locally stored in our object. So the usage is also very simple. Normal usage would be we have all the data, we construct the object, and then we use it. And the other use case is that we have to build this API object, pass it to a proxy, pass the identifier to the proxy, and we got it. It works. For Twitter, this is relatively useless because you have 140 characters to pick, so you don't want to save a lot of memory on that. But let's pick, for example, Flickr, and let's say you want to load 100 images. That may be a problem if you have all the images in memory in your RAM. So basically, you start sharing objects across different systems. You don't use the memory in your local system. And in general, you can make your objects locally look like you want them to look. And on a remote system, they may look completely different. So it works also as an adapter. It is quite complex to set up. You have to now override the constructor, build the Twitter API. The Twitter API must work exactly like the proxy expects it to work. So you maybe designed this Twitter API exactly for that. And the problem is that if you got a mistake somewhere or an HTTP request goes wrong, you also get a mistake, an error in your proxy code, the method that calls the method on the proxies. And also it's really slow. So this is suited for some use cases, for some others it's obviously not a good idea. But basically this is one possible use case of proxies. The other use case is lazy loading. Lazy loading is more like a general pattern. It is usually there for really, really expensive objects. And like database connections, input-output operations, very huge objects that take a lot of memory and that you don't use all the time. Or objects like hashes, which actually take a lot of time. You may take a second to compute a hash, and you don't want to compute 100 hashes altogether if you're not using them all. So again, this is not a proxy. This is something that you usually code in your your own code. And it looks like this. So what you have probably also done, or you're already doing it, you're still doing it, is having like this, a customer object, and a customer object, it looks like the tweet object that we had before. We build it with a DB connection, an identifier, and then what happens is that each time a method on this object is called, we are actually calling the initialization method. And the initialization method checks, do I actually have the data from the database? Okay, I don't have the data, let's go and fetch it. And then stores it locally. So that's basically it. It's like every method must be modified to intercept access to the data. And every method must call this initialization method, and that is really a problem. So basically now you have many problems. First of all, you have initialization logic mixed with data. A customer object is data. It's simple. It shouldn't know anything about the database. And that's also the other problem. You now have dependencies to the database. If you want to test this, you got to mock the database object. You got to do a lot of checks. You got to test every method one time more because it has to trigger lazy initialization. For every method, you now have another test just to check that lazy initialization is triggered. And it's not really optimized. I'm calling every time the init method here, and if I start adding more logic to avoid that, it becomes really ugly and really quickly. And it is, again, it's harder to test. It's not really a nice thing to test this. And it's easy to introduce bugs in it. And that's why we introduce proxies. There's two ways of solving this problem. The first way is by introducing a virtual proxy. Virtual proxy is an object that keeps a reference to the real object and basically calls method on that object. And the initialization logic is the only thing that this object does. The other solution is to use a ghost object. A ghost object which is more complex. It uses a lot of reflection, but basically it does the same stuff. It just doesn't have a reference to the real object. It has all fields set to null, and then we initialize all the fields when we start initializing our object. Let's start with the virtual proxy. I'm taking here, for example, an image object. And in this image object, I'm just passing the path to the image in the constructor. And what happens is that I am loading some file from disk, and this file is then stored in memory. I have this image, this JPEG image in memory. And then in the get size, I basically manipulate, I access this property and check, okay, give me the size of this image, give me X and Y for this image. And that's it. With a virtual proxy, I can wrap this object. So the constructor gets overloaded, and I'm now not using the path anymore directly. I'm instead storing it locally. And then I'm overriding every public method and triggering the initialization method. It looks exactly like lazy loading. I'm just having a separate class that does only this. And this is the only thing that it has to do. So every time I call getSize, initialization method is triggered. It uses the path locally and loads the real image object if there wasn't any. So the idea is that now I have two objects in memory. One is wrapping the other, and I'm basically calling method on the wrapped object once I have initialized it. And that can be really, really useful if you have large sets of data. So if you're iterating over a data set fetched from, again, Flickr or your hard drive, you can instantiate a lot of these proxies. And what happens is that I just initialize the object with the path. And as you can see, the memory usage doesn't grow. I mean, it's not sensibly growing. Of course it's growing, but it's not that problematic. As soon as I start calling methods on these proxies, the actual usage of memory and input-output is starting to increase. So basically, after I initialize the first object, I get 4 megabytes, and after I initialize the second object, I get then 8 megabytes. But in this case, I already spared 4 megabytes of memory, just because I didn't use the third image. So that can be really, really useful for that. So the first advantage of this is that now we have an object that does only lazy loading. It doesn't do anything more, and it doesn't know anything about the original logic of the object. It is better for performance, and anyway, the overhead is quite low. We're just calling this init method every time now that we're calling the public API of the object. It is quite simple to implement this logic. I mean, this was no rocket science, I guess. The problem is that we don't want to proxy this. We don't want to proxy data if we're sure that we're going to use that data every time. So if we have like 100 record sets and we want to display data for all of them, you won't proxy them because you now have 2 objects in memory for every item. And again, we have the problem of lazy failing. You now have fetched your data or your identifiers, and then you start iterating over the result set. And what happens underlying it is that your images get loaded. And as soon as an image is missing, you get a warning or exception. So that can also be annoying. And the other problem that is minor, but it's still a problem, is that you now lose the identity operation. You don't actually know if the object that you're using is the proxy or the real subject, because now you have 2 objects in memory, and as soon as someone is starting to use a Fluent interface, which I hate, I totally hate Fluent interface, okay? You are unwrapping the object, and now you have 2 objects in memory, or maybe in an array, and you can't compare them because they're 2 instances of the same thing, but you can compare them by reference. The other solution to that is the ghost object. The ghost object is an object. It looks exactly like the real subject. It has all properties set to null. And you can do that by reflection or any wizardry. There's tricks in PHP that you don't want to know. Again, it lazy loads. And the problem it solves is this identity problem. You don't have 2 instances of the object anymore. You have only 1 instance of the object, and it's totally faked. But it's really complex to implement. And this is what the ORM does, for example, because we have loads of objects in memory to track, and Doctrine is using that. So I made a simplified example. I'm just using the image example again. What we do here is it's basically the same constructor, the same getSize method. What changes is the initialization method. What happens in the initialization method is that I'm now building the real image, and then I'm localizing properties. So I basically say this image is equal to the real object's image property. This is a thing that you can do in PHP, because both objects define that property as protected. It's not really nice. And if it gets more complex, you start using reflection. It can get really, really ugly, but it solves that problem, if you have that problem. So, as you can see, the advantages and disadvantages are the same. The only other problem that is solved is this identity operation that is now valid again. And the other thing is this solution uses less memory. You now have just the properties of the real object, and you won't have all properties duplicated. And again, pick your poison. It brings problems. The other kind of proxy that I've been talking of is the protection proxy. This looks much like a firewall. So you can basically throw an ACL object to it and say, okay, this is my API, protect it. So you could basically build a file system object, and this file system object is a read-only file system just because you wrapped it in a proxy. And actually, it's more like a decorator. The difference between decorators and proxies is really, really small, okay? And there's always a blurred line between them, so don't take it too seriously. It may be a decorator in your opinion. I won't argue with that. This is how it looks like. I have an API object. I pass it to the constructor of my proxy. And then in this case, I'm passing a limit to the proxy. as a second parameter of the constructor. And what I do is I call doStuff, and this doStuff increases a counter at every run. And when I reach the limit, I basically throw an exception. And I say, this is remote API limit exception. It's a simplified example, can be useful. So if I use it like this one, so I want to limit, in this case, the access to the API to 50 calls, and then I iterate over the call, and I say, forever, please call doStuff on this object, I someone get a remote API exception. So it's transparently filtering access to my objects. I don't have any mixed logic. I don't have to code the XCL or the limits in my own API object. That's the point. My API object doesn't know anything about limits. It just works. And then I have this proxy, and this proxy handles this crap. But we are, again, modifying the behavior of our object. We're now throwing an API limit exception, which may not be expected by the client. So it may bubble up and cause a massive crash. So it's, again, pick your poison. It's a nice solution for some things. For other things, it's death. Okay? And the last kind of proxy I wanted to show is the smart reference. A smart reference is the most flexible kind of proxy. The idea behind a smart reference is to actually execute more logic whenever some logic on the real subject is executed. So you saw that in the talk yesterday about aspect-oriented programming. The idea is basically to decorate methods and execute logic before or after or override stuff. And again, this is one kind of implementation of aspect-oriented programming. So the idea is that you could cache methods that take a lot of time to execute. You could log stuff. You could trigger event stuff. You could trigger an event whenever a method is called. A particular method in your application is called. You trigger events and then throw them at some listener somewhere. And you actually, this is how PHP unit handles mocking. So if you use PHP unit, actually PHP unit, what it does when you call this get mock is basically this. So a proxy is built, and this proxy looks like a real object. And whenever you call a method on it, it says, aha, wait, this method was not expected to be called. Let's throw an exception. Or let's increase a counter and check that it was called exactly that amount of times. And aspect-oriented programming in general. These are really complex to build. So I made a really simple example. The idea is to cache a really small method in this case. And let's say I have this method here, do heavy stuff. And in this case, I used an annotation. It's just for the sake of the example. And I say aspect-oriented programming, LP, cache with a time to live or 3,600 seconds. So this method, somewhere there's a generator, and this generator basically builds a proxy that looks like this. I have now a constructor which is overloaded. I pass a cache to it, and the do heavy stuff method is overloaded so that the cache instance is used to basically retrieve data if there is any. And if there isn't any, I will just call the real method on the wrapped instance, and then I will cache that instance and return the real result. So is this clear, or is it too messy? This stuff is something that you don't want in your real object. Your real object doesn't know about caching. It just does its operations. Again, this is more like a decorator, okay? But you want to generate this stuff on itself. You don't want to write it by hand. It's a lot of work to write it by hand. So implementing a proxy in PHP. The poor implementation that I often see, and which is quite common, and that's just because PHP allows magic out of the box, is this one. So the poor coder's implementation is to just use the call method and proxy every method call to a wrapped instance of the object. And Please don't do this. Absolutely, don't do that. That's evil. The idea of a proxy is that it must respect the list of substitution principle. So every of the methods of the real API must exist also in the proxy. The signature must be respected. The methods must look like the parent classes. Everything must be the same. Internally, it can look completely different, but from the outside, it must look exactly the same. So, and this is not really trivial, because what happens is when you extend an object in your userland, in your code, and then you call it a proxy and then change a method somewhere, and you forget to update the proxy, now you have a bug that is really, really nasty and really hard to find out. So you won't find that bug. That's really hard to find. And also proxies are not nice. This is generated code. And this is actually a proxy for a single, an object which has one public property and one method do foo. Do you see how long this object is? And how many cases it has to handle? That's not nice. You don't want to write that. I mean, that's PHP, okay? Internally, compiled languages do also this crappy stuff. You don't want to read opcodes or generated assembly code, okay? But that's it. That's what a proxy looks like when you let some API generate it. That's why I wrote a component. I actually wrote it for last week's Dutch PHP conference. Once they accepted my talk, I started writing it, and it got quite popular. The idea is that you won't have to generate code on your own. I mean, you don't want to write the stuff on your own and introduce a number of bugs that is incredible. And it currently generates virtual proxies, smart references, and ghost objects. So it's also integrated in Symfony 2 and Zen Framework 2. Troll success. I actually managed to get it in there. And I'm going to show a couple of examples of how you use that thing to generate a proxy. So the first example is the virtual proxy. So you have a slow object, and I made it just for the sake of the example. And you have a sleep method, which waits for 10 seconds in your constructor. So that's, we assume that that is a remote object, or it takes 10 seconds to load. It's a large image coming from some remote system you don't know. And then I have the do foo method, which does something really silly. What I can do is, using this strange syntax here, please don't look too much at the object names, at the class names, because I'm really bad at picking class names, and you can see that. The idea is that I pick a configuration object, which is basically about optimizing stuff for production later on. I build a factory, and this factory is about lazy loading objects. And then I say, factory, create me a proxy, and this is the class name, the fully qualified class name for the proxy. And then I pass in a closure, and this closure is the initializer, so your init method. This is what gets executed when the proxy is initialized. And this initializer builds the real object, my slow foo, and then says, okay, the proxy is initialized. That's it. That's it for now. You don't need to do anything else. And then I can just call proxy to foo. This object looks exactly like the parent class. This was generated at runtime, maybe saved to TMP or somewhere, and that's it. I actually wanted to run it because I failed yesterday at the live demo. I'll fail again, I know that. Okay. So basically I have a cat examples test lazy, and this example test lazy basically has this foo object, which is really, really slow. It takes 5 seconds to initialize. And then I instantiate 1,000 of these objects. And then I say, okay, at the end, I just var dump the time I took to instantiate 1,000 of these objects, 1,000 of these objects. I call one time the method on the last object that was instantiated, and then I tell what time I have again. So if I run this example, yeah, it took a fraction of a second to instantiate 1,000 of these objects. That would take otherwise 500 seconds, 5,000 seconds actually. Okay, and then I called one time the method, and as you can see, the 5-second delay was moved away from my logic. The other example I wanted to show is about smart references. So the idea here is to call something every time something else happens. What I do here is, okay, again, I build this configuration object, forget about it, but the important thing is I get a factory, and this factory builds an access interceptor. And this access interceptor is basically a wrapper around this connection object. I pass in a connection object, and then I pass in 2 arrays of closures. And these closures are basically what happens before or after execution of the query method in this case. Basically say before query, run query being executed, and after the query, I say query was executed, it is completed. And then I can just run db query, and that's it. So let's see if I have an example for that too. I think so. Test intercept. So yes, we have basically class foo, and foo has a method do foo, and this method do foo echoes foo, exclamation mark. Then I have this factory, and I say, okay, before do foo, echo pre-foo, and after do foo, echo post-foo. If I run this example now, test intercept, okay, I get a pre-foo, foo, and post-foo. Okay? So you don't have to rewrite all your classes. That's the point in it. Okay? This logic, it looks ugly, but it's still better than writing all your stuff by hand. Okay? So you can do all your caching, and the example as shown before in here. And yes, I'm sorry again for the class names. Please sue me if your eyes are burning. Okay, you can use it with Zenfirma too. Basically what you say is that you configure the service container, and you say whenever my service name is requested, please use the lazy service factory and delegate instantiation to that factory there. And then I just provide a map of class names, because otherwise the proxy manager doesn't know what service looks like. So that's it. You just add this configuration to existing services, and the proxy manager will know that these services need to be proxied. That's useful when you have large graphs of dependencies, like you have an ORM somewhere as a service. You inject it somewhere, and you're never using it. So that's like milliseconds you're eating up every run, just because you're not using it, but you're still doing other stuff. So you can just proxy it, and the dependencies and all these milliseconds go away. Same thing for Symfony 2. In Symfony 2, you basically pick the service ID class and then say lazy true, and that's it. That's less flexible, but it's still very effective. So basically, also here, every time I request my service name, I get a proxy instead. And again, same discussion as before. So there's a couple of useful libraries I wanted to show, or to mention, let's say. The first one is the Doctrine Proxy Generator. I basically rewrote this the last year, and that's where I started using proxies extensively, because you need some confidence with it before starting to write this stuff. The other one is the Proxy Manager. Okay, I wrote it, so you're at the presentation. If you don't use it, I'll kill you. Okay? No, I'm just kidding. But seriously, check it out. Took me a lot of time to write it, actually. Flow by Typo3, they actually use proxies for a very particular use case. They basically inject dependencies in properties, and to avoid the usage of reflection at runtime to, let's say, access a private property somewhere, they proxy the object, and they say, and now they can access the property directly thanks to inheritance. So that's a quite smart use case of a very optimized service container. And then there's the CG library, which is a quite nice example of the visitor pattern. So basically, that's where I started writing Proxy Manager, but then I moved away from it because of license problems. Yeah, I'm leaving soon. The other library that I wanted to mention, and you saw it yesterday, or at last the people who went to the aspect-oriented programming talk saw it, is Lizashenko's PHP library, which is called Go AOP PHP. And this library is quite interesting because he actually uses code generation again at runtime. And what he does is he overloads your autoloader and replaces it with an autoloader, which is basically able to rewrite all your methods in your objects and inject and apply weaving and generally introduce more logic in your objects. So that's exactly the use case for the annotations with AOP cache, for example. That's it. That's the interesting stuff you can do there. So is there any questions? Are there any questions so far? Everybody fell asleep? I see. Okay, so I have a quiz. Who knows how to proxy public properties? Let's say you have a customer object and you have two public properties. And property name and surname, okay, very simple. How would I be able to know when the property name or surname was accessed? This is for PHP guys, so sorry for the others. But there's a trick to basically know someone is trying to access this property. Does anybody have a clue? Sorry? No. AOP is the way of introducing that. You must know the trick that AOP is using. That's cheating. You're asking me to use a library that solves your problem. I asked you what the problem is. How do you solve it? Yeah, using a library is a good idea, yeah. Okay, I see there's no clues. Huh? I report that back. French people don't have any idea about... No, I'm sorry. I'm just kidding. The idea is this one. So basically, I introduced this proxy. And this proxy, what it does is it unsets the parent class properties. What happens now is, since PHP is not really a pure object-oriented programming language, and since PHP internals are a mess, what happens is that now I can basically use set and get and isset and unset on these properties. Every time I will try to access the name property for reading, get, the magic method get will be called. And every time I try to do it for writing, this set method will be called. That's quite nice. I mean, it's horrible actually. PHP shouldn't behave like that, but it's expected behavior. I talked with the internals developers. So that's what it was. I don't have anything more for you. I hope you like the presentations. You can find the slides at the link there. You can fork them, so if you saw a typo, if you don't like my class naming, you can fork them and modify them. And you can follow me on Twitter, or more interestingly on GitHub. I'm Akramis. And that's it. Thanks.